as of right now, you guys probably have that at the bottom right-hand corner of your you probably have that on the back on that right at the bottom right-hand corner with all those correct. Now, what I want to do is right now you guys have side, angle, side, correct? Okay. We're going to add in 2 more today, and we'll probably add in the 3rd one next week. So right now I want you guys to add in, so let's see, we have side. You had a picture. You had the side, angle, side, and you probably have a picture. Let's add in angle, side, angle, and angle, side. There's going to be 2 other ways that we're going to be able to write these things out. And just like we had before, notice how we have 3 consecutive sides congruent to 3 consecutive sides. The next one was 2 sides were congruent and the angle in between them. Well, the difference between side, and angle, side, angle is, well, then it's going to be 2 angles in a row with the side between. So when you draw that out, angle, and the side in between. Now, we called that, when we had side, angle, side, we called it the included angle. Well, now that's called the included side. That's the only difference. Okay. So what we're trying to look at, when we're going through our proofs, none of the ways that the proofs set up and work themselves through change. What happens here is that sometimes you're going to have different means to show that it works. That's what this gets at. So some proofs will get you with all 3 sides in a row. Some proofs will get you 2 sides, the angle in between. Some proofs will give you 2 angles and the side in between. Or in this case of the last one, it'd be 2 angles in a row and then a side after. Okay? 2 consecutive angles and a side next to it. Angle, side. And that's what's nice about the lettering. It kind of tells you the order in which these things show up. Excuse me. So you have your all sides, 2 sides, the angle in between, 2 angles, the side in between, or 2 angles and the side afterwards. And that's kind of what we're looking at today. Shouldn't be all that. Really, then, it's just a matter of practicing and going through other ones that look like that with the extra perpendicular steps and stuff. Because if you have your progression sheet, you lose it. Well, at least write something down so that we have that to add to it later on, all right? Because when you have your progression sheet in front of you, you should notice that more often than not, the answers for everything are right on there. I have an example here of a proof that we're going to do next, and when you get through all of it, there's only 25% of the material in a proof that you have to come up with on your own. Everything else is on that sheet of paper. It's like cheating. Okay. It is, but that's the whole reason. The whole reason why we do this, so we can set these things up. So let's try this. Want that picture? Maybe. Actually, I did the triangles themselves, and then I hand wrote it in. I made the diagram via the smartboard, so I can't take credit that I can draw that straight line. We're just adding. This is 4-3. I don't know what the name of it is. And to be honest with you, as we get into these things, we're adding in more ways to prove triangles. I think it's technically angle side angle 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 side. Just remember that we're just adding to the next alphabet soup, if you will. Oh, dang it.  'Cause 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 We left our lights on and all that, and not a single soul walked up. But where we live, it's still such a really new neighborhood. So much new construction going on. I mean, there's a handful of houses, but not a lot. Most of the kids who were out trick or treating were all with us as it was. So, as you go through these things, what I want you guys to remember that it is so unbelievably important that you draw your pictures, draw your diagrams. Because when you have the diagrams in front of you, as you probably noticed as we go through these things, we always mark them up. And as we mark them up, we're able to kind of see where's the proof leading you? Where is it leading you to show that it's going to work? Is it leading you towards the side, the side angle side, the angle side? That's the idea of having pictures so that way you can reference them on those blue sheets. Yes, ma'am. The reason that I do that, I grew up, my high school geometry teacher, Mrs. Bender, did that. And the reason why she explained that she did it that way was because an angle is created by the portion of an arc of a circle. So this degree value within here intercepts a certain amount of an arc in a circle. So it's just referencing that an angle is created via a circle. It's a trigonometry thing. Plus, a lot of times, if I just did this, they start to look like L's. Or, it's just another way of writing it. It just cleans it up. Plus, when we use our tick marks and our triangles, we put little arcs in them around the angles. That's all. I mean, it was just how I was taught. My teacher did it, and it just, the next so many years, it stuck with me. She's still teaching too. I'm not that old. So, where do you start? What's the first thing you do? Yeah. You write them down individually. Don't try and write all of it out at once, because if you do that, you're going to mess something up. Yeah. Plus, by putting them down one at a time, it tells you to go to the diagram and mark it. So when I write down that I have angle CAB congruent to angle DAE, I immediately go to my diagram and I make my tick marks. After I go through that one, there's obviously nothing else that I can do out of that. I just marked it and I'm done. I go to my next VA is congruent to EA. And lo and behold, I go back, and what do you think I do to my diagram? Yep. Now, we have our third given. So far, you had to do no thinking. All right. Go to the next one. It says that angles B and angle E are right angles. Now, if I'm not mistaken, on our sheet, we don't have anything that says if given right angles. But we do have this information written down somewhere. Right angles are formed when things are perpendicular. Remember that? So you can kind of cheat your way through this one a little bit by looking at the perpendicular portion. If you look at the perpendicular portion, the first thing it says, state the right angles that are formed. After you do that, and the reason you would say that is because definition of perpendicular. Well, our case, the right angles were formed was given. After that, it says to state that the right angle is congruent to the right angle. Reason, all right angles congruent. So we talked about that in second hour. In second hour, I said, you know what? Why don't we make our an extra square just to have that, so you don't have to try and find it. So it's not a bad idea. So let's do that real quick before we go on. Let's make another quick square, and we'll say if given right angles. If given right angles. Well, it's super straightforward. If you're given right angles, then you're just going ahead and say right angle congruent to right angle. So we'll state our example. I'm just going to use the same example we have in that proof. Angle B and angle E are right angles. So we'll write that. Angle B and angle E are right angles. We'll say that's given. That just means angle B is congruent to angle E. And my reason? Sorry, it was just kind of funny. I went through on the. I'll set it. So I'll just say that angle B is congruent to angle E because all right angles are. I thought that was, I don't think it was totally 100% necessary that we write that one out, but it's not a bad thing to have in front, just in case. That's why we write that through. So let's go back to where we were at with the proof. Oh wait, did anybody not get that down yet? Let's go back to the proof then real fast. I have right angles, so what am I going to say next? Well, what specifically am I going to put down next? Yeah, so I'll write angle B is congruent to angle E. Reason? Very good. All so lastly, what should I do to my diagram? Make the little what do we have? Angle side. Okay. Yeah, very good. We have angle side angle. Go away. Go. No. No. So you wind up with congruent triangles. So if you really start to think about what you have given versus what you have to come up with on your own, there's what, 10 things you wrote up there? 5 statements, 5 reasons, there's 10 parts there. How many of those did you have to try to figure out on your own? 1. You only had to figure out one thing on here by yourself. You only had to figure out that. 90% of that proof was done via your progression sheet. Sorry. I don't mean to laugh, that was pretty funny. So when you're working with proofs, guys, honestly, that progression sheet tells you how to do everything. Right? So that wasn't so bad, was it? Let's see, where's the next one? Okay. Change this up just ever so slightly. No, I've changed it from what that said here to that. We'll prove those. And this will be a good example where you're talking about perpendicular stuff. We got a couple of perpendiculars. Yeah, we did. Yes, prove the triangles we had inside. Oh, from yesterday? Oh, we're doing one that's very similar to that right now. Yeah, this one I think might be the exact same thing, except this one has an angle bisector, the other one has a segment bisector. So we have segment BD is perpendicular to segment AC. And then it says that segment BD bisects angle CDC. And then it wants you to prove that you have triangles ABD, triangle C. So we have perpendicular, according to your sheet, when you have perpendicular, you have two things that you can automatically say. So what's the first thing that you say when you have perpendicular according to your sheet? Say at the right angles, and then after you say the right angles, what do? So, first things first, write down the given. BD all right. Since that's given, and I need to figure out what my right angles are, sometimes it's not a bad idea to just mark your diagram and figure out where they show up. Well, that means at angles ADB and CDB. Those two. So we know angle ADB and angle CDB are right angles. According to your progression sheet after you write that down. The reason is, try again. There you go, definition perpendicular just ahead of you. Oh, I can't write straight at all, man. Definition of perpendicular. Now, Christian, I could say that the right angles are congruent to each other. Angle A, DB, straight off of our blue sheet. All right angles. Is there anything else left to say about perpendicular and the right angles according to our sheet? Nope. So we go to the very next step. It says that BD bisects the angle ABC. I'm going to scroll up here so I can write it better, and I'll roll it back down. BD bisects What does an angle bisector do? Makes two equal angles. That's an angle and a half. So on your progression sheet, it says to do what then? What's that? Angle congruent to angle. Okay. So I go to angle ABC, the large angle, and I have to figure out what are the names of the two smaller angles that are formed. ABC is the big angle. It cuts down at BD, so it's nothing more than these two. So we write it down because that's what the definition tells you to do. So it was ABD, angle ABD is congruent to angle CBD because of the definition of an angle bisector. Okay. So now we start thinking about what do we have left to show. According to our diagram, we have two consecutive angles right now. We have two consecutive angles set up. We have an angle and an angle, which means we have to find a side after the two angles, or we have to find an angle, a side between them. Which one is you're going to be able to find? Side in between. All right? Yeah, the side in between, and why do we call that? Or what do we call it? Excuse me. Reflection, yeah. Side in between. So you have BD. Reflexive property. Are you done? Well, yeah, now we have just left to write out the triangle part, yeah. I can rephrase that. Have you shown everything except for listing out the last bit? So all we have to do then is copy down what they want you to prove, ABD and all that. So copy it down and write it here. And our reason that we found that out to be is not angle, angle, side. That means the side would have been after the two angles. The side in between the two angles would be, there we go. All right, now let's think about this proof. 1, 2, 3, 4, 5, 6, 7. We had 14 steps there. We had 14 total pieces to that. Okay? How many of them did you have to figure out on your own? 3. You only had to figure out 3 of them on your own. Out of all 14 pieces that are here, you just had to look at the diagram to figure out that this happened, and then you had to look at the diagram to figure out which one of these happened. Sir. There's some fun people on the background stuff. So out of the 14 parts, you only had to figure out 3 of them. I'm no math major. That means that 11 out of 14 parts, basically 79% of that proof you had done for you. What I'm getting at here, guys, is you really start looking at this stuff. You know, the first 2 proofs that we did, the first one had 10 steps, you basically had to get 1 of them. This one had 14, you had to get 11 of them. So let's see, that's 20 out of 24 out of the first 2 that we're looking at. So 20 divided by 24. 83% of the proofs that we have just done, these 2, came directly off of this. which means that if you don't get 83% on the quiz, really what you have to come up with. It's like I was saying, 15-20% of each proof is something that you have to worry about coming up on your own.
Okay, sorry.
Ola!
Want to buy something? Did I talk to class?
Anna's already out.
Okay.
There you are.
Awesome, thanks.
Remember we talked about she's just a messenger. Trust me, if you go up with a smile. All right. Look, that look was about to burn right through me that time. That helped perpendicular? Verbatim. You didn't lose it completely, have you? Go for it. Don't have to worry about it. This example gives you everything except for one step. BC, congruent, CD, get BC, CD, marked. I go again. B and D are congruent. Marked. We're back at the idea of I've got an angle and a side, which means I have to figure out which way am I going. If I have an angle and a side, well, that means I could have side, angle, side. I could have angle, angle, side. I could have angle, side, angle, depending upon where I place my other part. So when I start looking at it just by moving those letterings around like that, that's the only thing that's left for me to show. The angles. Angles 1 and 2. Why are angles 1 and 2 congruent? They're vertical. And the reason is vertical, angles, congruent. And now you have triangles. Okay. It's the idea that you go so far into the proof, and then you just have to make that last little looking at it. What's left that I can, well, in this case, infer? Remember when we talked about when you look at diagrams, there's certain things you can infer? Vertical angles is something you can always look for. Just like when we had line segments or angles before where we can see whether or not things were linear pairs. It's the same basic principle. When you look at a diagram, you can infer that you have vertical angles. You can't assume that things are congruent. You can't just go ahead and mark up sides. Oh, their sides are same. You can't do that until you know for certain that something occurred. Okay? And that's the idea. All right, so this will want to be an angle side. Okay? We have one more. Oops. Got to save the right file. Last one. Well, I have a minute or two to try to start that one. Really got a couple minutes to start this one. We'll probably just get this one started and see what you can show. Excuse me. Tomorrow what we'll do is we're going to run through all of this tonight, and I'm going to try to get back to you guys everything. Now, I know we're running a little short here. Let's just walk through the diagram and say what you would have to do. If you're given right angles, what would you say? Right angles are congruent. So you'd write down, you have your given right angles. Your next step would be to mark them and then say that those two right angles are congruent. Correct. If you're given a midpoint, the next step, what's the midpoint say to do? In this diagram, midpoint says that you have segment congruent to segment. What are the two segments that would be congruent? AB and BD. Okay. You have a side and an angle. What's left? Okay. What's the side? BC. Why? It doesn't say that. Why is BC congruent to itself? Flexive thingy. All right. It's shared. When you have that shared side, it's what's called reflexive. So why would those two be congruent? Side angle side. Do these four, please. Okay. Do those four for tomorrow. Guys, you have examples of every single style we've done in the class the past 3 days, or however many days we've been working more and more proofs. So none of those are going to be straight or scary, I hope. We will have time to go over some of those tomorrow. Won't be a problem to answer up any other left minute questions. When the quiz comes around Friday, there are 4 proofs on the quiz for Friday. Yes. You'll be able to use that fresh sheet. I will get some fresh copies in case you want to write out your own. Yes, ma'am. The progression sheet? No, because it's really hard to put proofs up on finals because it's multiple choice. So let's just say the first stuff that you put on the final. It's like, what's the next step?
Oh, okay.
So you'd be fine. All right, we'll go through that. We'll do some more of this tomorrow.